So this is more a meta approach than a specific approach. It's a way of getting insights rather than a technical nuts and bolts method. The inspiration came to me when I was thinking of the manifold hypothesis for neural nets, that they, when they're classifying, they're finding a particular shape, like pandas or gibbons within the image space. And adversarial examples are sort of submanifolds or subshapes, weird subshapes inside these shapes. Probably a very low dimension, but if you have an optimization process, they probably score high in that. So I was thinking, well, if I was the AI, I'd avoid things that maybe put me on submanifolds. And that was sort of one of the first things where I was thinking, maybe these problems are solvable by considering them from a different perspective. I had a similar thought when I started on why is Goodhart laws bad? And when I thought that through, I realized that our usual fear of anthropomorphizing was actually leading us astray in this situation, surprisingly. I'll get back to that. So we don't have an AI. We don't have code for an AI. We don't have a theoretical model for a safe, effective AI. So we can't solve and most of the questions that we're working on, we don't actually have them in any formal sense. So we can't solve these by ultra formalization proof at the highest level. Instead, we need to form some abstractions and reason with those. Abstractions like models are always wrong, and some of them are useful. And different abstractions are useful for different purposes. One of the best first abstractions was do not anthropomorphize the AI. And when you start thinking in that way, you realize that in your informal reasoning, we're using our own black box, our own intuitions to reason about what AIs do, and that's wrong. Like anything like AIs will value complexity, hence blah, 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 or these kind of things, we're projecting human ways of reasonings on AIs. And that is clearly wrong, and learning to avoid anthropomorphizing opens up new ways, new valuable ways of thinking on AI. However, I think that too much emphasis on avoiding anthropomorphization blinds us to certain other aspects. And when I was looking at why is Goodhart law bad, and I delved into it, and I have various posts on this, and people agree or disagree, and there's a big back and forth. But one of the things I realized is that Goodhart law is not bad in the context, in the models that we were thinking of. We were thinking, this is a model of what an AI looks like. Goodhart's law is bad, let's avoid it. But if you look at that formal model, very often, Goodhart's law is not bad. So but for us, we know that Goodhart's law, we expect it to be a problem. So the problem was that we were not actually putting enough of our own preferences into the model. We were considering it at a too abstract level, in a sense. That's one way of thinking about it, but these sort of things cause me to think. By the way, this is a very clean post picture of everything that's going on. It was a lot more messy than this, but this caused me to go and think, if I was the AI myself, trying to avoid anthropomorphization, trying to avoid too much excess information, can some of these problems be solved? And then I've done a series of posts based on that. The first one is just on image classification, which was one of the original inspirations. So this is the famous pandas plus noise equals gibbon. And I was thinking, again, as if I was the AI and I was being fed these, basically, if I knew the concept of adversarial examples, but not obviously what a panda or a gibbon was, can I avoid this? Can I start, as I say, looking for points close to it, looking for evidence that this image has been selected by an optimization process, adding noise myself? It seems the sort of thing that I could do. And of course, since I could do it as a well-intentioned AI, this then suggests the sort of formal method which we as AI designers could inject in it. But looking for adversarial examples seems like something that is strictly easier than fully defining what pandas and gibbons are. There was another smaller post. The second one was on acting in the world. If an agent had a lot of experience of a red door and were then put in a situation where there were red windows or blue doors, how should it behave on that? And this connects with the sort of good heart not being too much of a problem, because there are sort of conservative policies here which cover as much as possible of the realistic options. Does it want you to go to the red window? Does it want you to go to the blue door? Does it want you to spend time at one or spend time at the other? There are a variety of different reward functions that correspond with the initial one. And so this sort of is developing into a general idea of extending models, which I won't go into here. There was the extremal good heart idea, which was the idea was a cancer curing AI trained by apprenticeship learning, and you wanted it to be able to, say, blast the cancer cells with a laser, but you didn't want it to dissolve the human with acid.
Did I?
Both of which would completely eradicate the cancer cells, and neither of which the agent has seen. And what I saw is that there are certain things that are correlated with the training examples, surviving the operation, surviving for some years after. There are some negative things that are also correlated, like complaining about pain. The ones where the operation fails have other things to complain about. Being more prone to dementia, that's a negative, but it comes from surviving for more years after. And there's some random things like paying more taxes than thanking the surgeon. So the first step was dissolving the patient does not have these features. Killing the cells with a laser has some of these features. So this is a way of going beyond models. Again, so these are not sort of, these are insights which came to me through this way of thinking, not that they derive, other people could derive them from other routes. And finally, I think the most interesting or unique or precise result that I got was when I was thinking of mesa-optimizing. And I was thinking of it as I am a human in a corporation. I run one of the divisions of the corporation, and I run this for the benefit of the directors. And thinking about this and thinking about how these organizations succeed and fail, I realized that there's a big difference between a mesa-optimizer that is aligned and one that is controlled. An aligned one is one that wants what the board wants. it's a perfectly, it has those goals, and a controlled one is one that the board can understand and that does what the board wants it to do and informs the board of what it's doing and those kind of things. And there are very different, basically it's a very different situation if you have an aligned subagent or a controlled subagent, and you have to treat them differently. And making a mistake one way, like a controlled subagent that you think is aligned, is a very bad idea. A aligned subagent that you think is controlled is not so much of a problem. But anyway, this sort of opened up a small new technical area in this thing, and it came about because I was anthropomorphizing or thinking from within the AI a bit more than I'd been used to. Okay, that's my sort of brief overview of why I went this and what I've used it for. And stop share. Cool.
Thank you very much for your presentation, Stuart. So I guess the first question should go to Scott. What are your thoughts on this?
Has access to the robots? Presumably,
yeah,
they have a map of the tunnels because they would have mapped it out to navigate it.
Somebody's talking. So for the, I don't know, so starting with the image classification example, it seems like, I don't know, I'm it seems like, yeah, you could do something where, I don't know, an example of the kind of thing that you might do is you might like add some noise to the image and like kind of like average the values of what you would predict about all the images that are nearby according to the model that the adversarial example is like coming from. So like all the things that are nearby in like pixel color space, which seems to me like something that you're thinking about from the outside. And to the extent that we want to call the adversarial example an adversarial example at all, it's because like it's being adversarial to the specific way in which the neural net is working, the way in which the image classifier is working, and like it's like like the adversarial example is like chosen. It's like notion of nearby is like its notion of nearby is like a function that's like trying to diagonalize against the specific image classifier. And it feels like when you're saying like, I can deal with adversarial examples, you're like using the fact that the example is adversarial to something else as opposed to adversarial to you. Do you think that's true?
Yes, that is a valid criticism. I think I mentioned it in the posts. The aim when I was thinking that way was, can we get rid of adversarial examples in ways that are strictly easier than fully defining what a panda and a gibbon are in unambiguous categories? And in the what is the thing when you get a message that is designed to mislead you but technically true? What was that? I think was Abraham working on that. I'm not sure. It's when you get information, when someone sends you information, the information is true, but the source is extremely manipulative. So in those situations, you try and compensate for your knowledge of how manipulative they are. They're trying to compensate for your compensation, and so on. This is what I was ultimately hoping for, that if you know that some entity has access to your code and is trying, or maybe some black box access and is trying to fool you, it should be doable in many cases to make yourself less foolable.
Yeah. Yeah, there's this question that feels like a central like binary question for to me for like this general class of thinking, which I don't know, I was reminded by with what you just said, which is I don't know, it feels like there's a class of solutions. There's a class of solutions that corresponds to like explicitly modeling the way in which you might be wrong, so that you're like, like here's like the way in which I might be wrong, and I'll kind of like.
I'm having flashbacks to several episodes of Doctor Who involving dead people in spacesuits.
Where is that coming from?
I think there might be someone behind Stuart.
Sorry, that was my fault. I hadn't.
Okay. Sorry. Yeah, so it's like there's one class of solutions that looks like trying to like explicitly deal with the ways in which you might be wrong, and trying to like when you said like there's something that's like updating on the fact that the person is trying to deceive you or something like that. It feels like a like active reaction to things like good heart, versus there's a more like passive thing where it's just like don't optimize too hard or something like that. And it feels like these things are kind of different types, where like one kind of like tries trying to like come from above, and one's trying to like come from below or something like that. It feels like these things are of different types. Does this make sense to you? Or
Yes, but I think there are some things that seem to be in the middle of that. Like one of the things I was looking at is detecting optimized images. So if I have my neural net plus my extra module, things that are optimized to fool my neural net look different from normal images. So I as the AI against a not infinitely smart adversary, well, first of all, I should be able to detect images that are designed to fool the lowest level of my neural net, and I should be able to sort of swallow my tail and diagonalize myself to some extent, and sort of detect images that are meant to fool the entirety of me, at least to a level that makes them less effective.
yeah, there's a sense in which.
So to answer your question, so detecting over optimization in the images aimed at myself.
Yeah, I mean, I feel like over optimization could, at least in principle, be diagonalized against you also. Like whatever your method for detecting over optimization. I'm not actually sure about this, but it feels like whatever your method for detecting over optimization, you can kind of find things adversarial to that.
An arbitrary intelligent adversary, there's nothing I can do.
It's not actually obvious to me. It might be that like the problem of detecting over optimization is like an easier problem than detecting a panda, in the sense that like you might actually be able to be robust in your detecting over optimization thing. But
it's in this kind of area that I was thinking, and that that this way of thinking directed me to.
yeah. Should I like alternate questions with somebody or something? Should I like every once in a while have somebody else jump in?
Well, no one has raised their hands. I have some questions, but they're probably of poorer quality. So please go ahead.
Okay, I'll just keep talking until somebody jumps in with a question on the chat.
So I have something to add, I think, which is that for current, like for the AIs that exist today, adversarial examples do look different. They are detectable, and yeah, yeah, and then you can take from that what you want if you believe that that will work on like higher intelligences.
Mm-hmm. It's an area. It's an area I think worth investigating. As your adversary gets smarter, as the AI itself gets smarter, is there? Who do we expect to win in this kind? I say I haven't investigated it. These were just avenues that were suggested to me, but it does.
So there are papers on this. I haven't read the papers. I have read the alignment for newsletter that summarizes the papers, but that's I know there exist papers who look at like how are adversarial example different, and you can sort of imagine it as okay. There's image space, which is like highly multidimensional because it's like every pixel has 3 dimensions because 3 colors. And then there's like the manifold that is embedded in this space, which is like things that are actually what photographs end up looking like. And then the adversarial examples are not on this manifold. They're sort of off. They're like outside how real pictures actually look like in a way that is not detectable for humans, but is detectable by AIs.
Well, I mean, at the meta level, the photo that's supposed to be a gibbon looks like a panda, and we can tell that, and we aren't using high level processing to do that. So
there is some high frequency features that we don't detect, but the AI is actually using in its classifications, and those high level features do look like a gibbon.
Yes, but what I mean is the fact that we can see a panda and tells me that there's something different about this image, and I fully expect that there's ways of getting the AI to detect it. I've seen some of your papers, but I'm just saying in principle, we expect that the AI should be able to detect it. I haven't really seen anything about the sort of diagonalization argument. You could say that GANs are a little bit like that, maybe just so, or so not necessarily GANs, just sort of general adversarial constructions might be like that. Maybe the Nash equilibrium or the final thing of that, you get something that is not as good as a perfect classifier, but and is not completely immune to adversarial examples, but is hard to fool and is decent.
So I wanna draw attention to something which I think might be a disagreement that I have with you, but I'm not actually sure, partially because I'm not actually sure what I think. And I think I tried to point it out before, but I think I maybe failed to point at it. So concretely, I want to point at the example where like I have a utility function, but I have some uncertainty. So basically like the red door, green, the red door, blue door, red window type example. And I want to generalize this to something where it's like I have some like distribution over utility functions that I'm kind of uncertain about, and I'm trying to be conservative in some way, right? Or I guess that's not the main problem. It's like you're proposing this class of solutions that looks like I have this uncertainty over a space of utility functions. I want to like be conservative about like doing well according to all of the utility functions inside this space. Would you say that's accurate?
Could go to the end of what you're saying.
Okay. And I want to specifically contrast this with approaches that look like not pushing too hard in the directions that might cause things to go apart. So like my space of utility functions like is the reason why I have a space of utility functions is because I've like trained on some examples and like there are things that are kind of out of distribution, and I could be like, well, I have uncertainty about these things that are out of distribution of things that I've trained on, and in cases where I can't like ask for more information, I'm then going to do something where I kind of try to be conservative and maximize all of the utility functions a little bit simultaneously or something like that. I don't know, does this feel like a fair classification of the kind of thing that you're trying to do?
Well, it's at least given me enough to do a rambling answer.
Okay. And then I want to contrast that with the class of approaches that look like just don't push so far out of the kind of things that you were trained on. Where it feels like one of them is like, let's try to like tabulate all of my uncertainty and figure out all the different ways in which I could be wrong and make sure that I like cover all of them, versus the other one is like, just don't stray too far or something, which are like two different ways of approaching conservatism. And I'm uncertain about two things. I'm uncertain about whether these are like different, and I'm uncertain about whether I actually think that it's better to try to approach ways that look like don't strain too far as opposed to like tabulating all of the uncertainty. But it seems to me like you're pushing. I'm reading you as pushing for doing something that's kind of like keeping track of like uncertainty, like explicit uncertainty of a lot of different things I might be trying to optimize for. I'm curious about if you have any comments on that.
Well, so first of all, on the conservatism and going beyond the sort of training environment, there's a lot of that in the post that I emailed to you a few days ago. That's a fundamental aspect of it, you could say. So that's the bit that's dealing with that conservatism and when you need to be conservative and why quantizers are not sufficient, in my view. But that's still sort of private, so I won't go into that too much. But I'll contrast it with the other aspect that you're saying. So here is a link to something I wrote, which was when good hearting is optimal. And I basically, just to take the very simplest example, if you are a robot and you're hesitating between going left and going right, and as soon as you've done left or right, it's over. You get your reward or you don't, and you have 50.1% probability that it's left and 49.9% probability that it's right. This is a pure good heart situation. You just choose the optimal policy, which might be disastrous compared with the other one. You just maximize utility. It's pure good hearting, and it's clearly the right thing to do in that situation, because of the other things, that it's linear, you do it once, it's closed, you can't correct it. So that was the thing that got me thinking, so why do we fear good hearting? And we fear good hearting, I realized, because we don't expect the situation to be like that. We expect the situation to be different. Like in that post I listed, we expect that there's going to be diminishing returns, that value is fragile. We expect that, that's the biggest of it. This is why we don't like good heart, because if we just choose naively a top option, basically, if we choose a top option, we expect that this will be disastrous. Is the reason why we fear good hearting. And then I was thinking, well, if we add that information, if we add the fact that we expect it to be diminishing returns, that we expect to have value fragility, that can all be done, included in a very Bayesian way across all the utility functions. And when we do that, a chunk of the good heart problem goes away. Now, in that post, and probably in some things, I'm implying that maybe most of the good heart problem goes away. In the post I emailed you, you can read it as sort of a tone of maybe very little of it goes away, or that's not the fundamental problem. But basically, the post that I've just sent here and linked to, adding more information about why we fear good hearting removes a chunk of the problem, and I think that this should be looked into. And this, if there's still a good hearting problem left after that, then that's a separate other problem. That is maybe the moment to be conservative on top of the just being Bayesian. And I have noticed that Linda has put her hand up several times there.
Yeah, so I'm confused when you said that the choosing between the 51% and 99%. No, okay. So I don't think you have the same definition of good heart as I do. So I just wanted to ask you how you define good heart.
Well, I define the good heart style behavior as naively picking a simple or a single utility function and maximizing that far beyond its area of applicability.
So you mean that the AI picks its own, or do you mean when we pick it, or both of the cases?
Well, let me develop the example a little bit, and to show where we get the actual good hearting. Suppose that you could go to the left, you can go to the right, you can stay. It goes on forever. There's a discount rate. You can stay on the left or you can stay on the right, and one of your utility functions gives you a reward for the logarithm of the number of times you stay on the left, and one gives you a reward for the logarithm of the number of times you stay on the right. And there's also a discount function. Given this, the optimal behavior is, well, go left because that's the best, stay there for a certain amount of time, go right after a certain amount of time, stay there for a certain amount of time, and fluctuate back and forth according to the various parameters here. And this kind of behavior seems very sensible and very much what we would want. The good heart behavior for that situation would be go left and stay there, i.e. picking naively the best option and sticking with it. So if you want, I distinguished a good heart style behavior from a optimizing behavior. And what I noticed was that a lot of the problems with good heart come because it optimizes a narrow, under-specified utility function. And that's a problem. But if we incorporate information, such as this is a narrow, under-specified, or you don't have enough information, and our reward functions are diminishing returns, and the values are fragile, and then say, okay, given this information, naively maximize expected utility, you tend to get behaviors that are a lot better. So if you want, yeah.
So I'm not sure that I actually agree with like calling the thing that you're calling good heart, but it feels to me like there's a sense in which, like, I don't know, we have some proxy objective, and then we have some like true objective, we have some proxy objective, and the proxy objective is noisy in some way. And if we're like in this situation, there's like kind of two paths forward, or like you want to do some combination of these probably, but there's like two paths forward. One is like figure out what information we're lacking and gain more of that, so that we like figure out the way in which like the things might be diverged and like put that information in so that they converge more. And then there's also like generically try to figure out ways to make it such that, in spite of the fact that our thing is diverged, we still don't things still don't end up badly.
Yeah, so the proxy, I think when you mentioned the proxy, I can phrase what I was saying better.
Okay.
If we have a proxy reward and we know that there is uncertainty about it.
Sorry, what do you mean by there is uncertainty about it? You mean we know that it's
Well,
not?
we know it's a proxy.
Okay.
We know it's a proxy, and maybe we have some idea how it might relate to the real reward, but we know it's a proxy.
Yep.
Then I'll define the good-hearting behavior as naively maximize the proxy without caring about, just maximize the proxy would be good-hearting in that situation. And what I was saying is that in many situations, with the kind of utility functions that we use in toy examples, that is the optimal thing to do. But if we then move to more realistic utility functions, incorporating our judgments about the various things I'm talking about, then that becomes the wrong thing to do. However, if we incorporate that knowledge into the algorithm, so it has the proxy, but it knows that the proxy derives in this way, and this is the shape of its uncertainty, then, so maximizing the proxy would be good-hearting and really bad. Maximizing the expected utility with the proper form of the uncertainty seems a lot better. Well, is a lot better. So I think there was a confusion conceptually between the two. So I don't know if people were confused, but I definitely was, that good-hearting was, or that if you want, maximizing expected utility was the same thing as good-hearting, was the same thing as maximizing the proxy, and that these are distinct. And that,
Yeah. So yeah, I'm like I'm really curious about this. There's something where there's being able to look at a distribution, being able to, so yeah, I'm sitting here, there's a true value, I don't know what it is. I have two objects. I have this proxy value and I have a distribution over the true value. Maybe let's say the proxy value is just like the average overall.
I'm not sure.
Or the
distribution, or
wait, let's say the proxy value is the most likely.
Sure.
Or
Let's say that
like
the proxy value, the proxy value is the most likely. And wait, so does what you're recommending like equate to optimize the average as opposed to optimize the most, like, does your thing correspond to pay attention to the distribution, optimize the average as opposed to optimizing the most likely? Or
basically, well, yes. For some, if you take average as weighted sum of utility functions weighted by a probability.
Yeah.
If you want, the shape of the plausible utility function is not a ball. It's not a ball around the proxy. It has a different structure, which is why the average is not the same as the proxy. The mean and the mode are different. Is the easiest way of saying it. Potentially very different.
Yeah. Yeah, so there's another thing that I felt like you were saying, maybe you weren't, which was something that was like, I don't know, I feel like there's something to being aware of my own fallibility that is not just like averaging over the things, where you're like, there's some sort of like being aware that like things might actually be diagonalizing against me or something like that. Were you trying to point at something like that too, or not?
I agree that it's potentially this case, but what I wanted to point out in the post I've sent to everyone here and other similar ones is actually just being Bayesian naively, but doing it properly, gets you a surprising distance. It's plausible that it won't get us the whole distance. As I said, have a look at the one I emailed.
Yeah, I haven't looked at the one you emailed yet, so I might accidentally say things that are in there.
Don't worry about it. It's my sort of the thing I've been working on during all of lockdown. But putting that aside, the thing is that doing the Bayesian stuff properly seems to get us a surprising amount of the distance. And then, of course, yeah, there's various conservative things that you can apply on top of that if we feel like it. But I'm not doing that yet because I wanted to see how far the naive Bayesian approach with proper uncertainty got us. Can I answer the two questions that have popped up in the chat?
Sounds good. It'll give me time to think.
Okay. So from Ricardo, everyone can read it, so I won't need to repeat the question. So from Ricardo Volpato, yes. The question is, this is not just change the problem. We have good ideas about how this uncertainty is shaped. That's the point of why we fear Goodhart, is because we know that our values are complex, for example, that there is diminishing returns, that that humans are fallible and can be corrupted. This information is not present in standard Goodhart problems, but now we can put it in terms of uncertainty over the proxy. So it changes the problem. I wouldn't say it just changes the problem. And for the question from Roland Philikas, can you propose? I think it's because, well, I can only speak for myself because I've been working with Goodhart problems for years, and I didn't notice anything like this until recently. But I think we are too focused on the human version of the Goodhart problem, where the human is antagonistic. The principal agent problem is basically what it is, and there the agent is antagonistic or at least misaligned with the principle. And here it's basically, can the principle specify in enough detail to not leave any wiggle room for the agent? The principle cannot specify something like, well, I'm a bit unsure, it might be the left one or it might be the right one. Think a bit longer about what I really value in this way, and you'll come to the right conclusion. And that will never work with a human, because all that they need to do is come up with a plausible sounding justification for why whatever was the right one. But if you're dealing with an AI, then you can say things like that if you specify well what you mean. You can allow a superior intelligence to figure stuff out about your own values, which you can't do in the standard Goodhart problem. So you notice that this is touching upon thinking as if I were a well-intentioned AI kind of thinking. And that's, I think, that was one of the key things, is that in the AI version of the Goodhart problem, we can have the agents being much smarter than the principal and figuring stuff out that the principal doesn't know and can't measure, as long as it's well specified.
So
You're supposed to start with the starter.
I'm inclined. Okay, so I'm inclined to say that if it were the case that we could specify a distribution over utility functions such that like our true utility function has non-trivial probability, we would have solved almost all of the value alignment problem. Like almost all of the part of alignment that is like trying to specify values or something like that.
When he's talking.
And so I kind of feel like
I mean,
we're not going to be working with distributions that have like a true value inside them.
what you're saying is trivially easy to do. Just do all possible reward functions or value functions in existence with some weight.
Okay, so if we average over all possible value functions with some weight, well, I guess I'm trying to say something like it feels like examples in which like there's like a small number of things feel like they might be misleading.
Yeah, but the thing that I'm hoping is that we can break symmetry. The reason why averaging over all possible utility functions doesn't work is because every utility function has an antagonistic. There's u and there's minus u. As long as they're both there with similar probabilities, they might as well not be there. You can just take them both out when you're averaging. But can we break the symmetry? Even what I noticed a long time ago, even knowing there is a Goodhart problem, this slices the space in half. Half of the utility functions do not have a Goodhart problem. They have the opposite of a Goodhart problem.
Wait,
but
what?
These are nothing like the ones that that they prefer that you maximize the proxy rather than the average.
Okay.
And so just knowing that there's a Goodhart problem, we've sliced away half of them, which is nothing, but at least it shows the break in symmetry. And the more of the stuff, the meta stuff that we know about ourselves that we add, the more symmetry we break. So if you want, take the trivial thing, which is every utility function is there. This is terrible because when you average it out, you get nothing or you get something absurdly simple, and then start slicing away by adding our meta knowledge and still keeping average. But I think that this process can go a long way.
Yeah, I mean, it basically feels like training or something. You could have like,
Yep.
you could start with like a big prior over all of the possible utility function, and then you could ask a bunch of questions that are like, do you prefer this world to this world? And each of those questions should like cut your space in half or something like that.
And training which distinguishes a utility from its negative is a different type of training from one that doesn't tend to do that.
Yeah. I don't know. I'm specifically thinking of the kind of training that is like, do you prefer, or a type of ruling things out, which is like, I don't know, playing Guess Who and saying like, do you prefer this one or this one? Okay, we're going to cut half of the utility functions out and repeat this until you're left with like one.
I'd more be interested in things that sort of cut between diminishing returns and increasing returns, for example. Because increasing returns mess up things when you average them.
Okay, so you could say, do you prefer A or do you prefer a X% chance of B and a 1 minus X% chance of C? And you could ask different lottery questions in order to cut things in half. And then,
yeah, I think those are more the things that I'd be looking for. The other stuff is good too, of course, but they less include our meta knowledge.
Yeah. So I mean, I basically just like absolutely agree that like working with the average is probably going to end up better than working with the mode. Working with the mean is just going to end up a lot better than working with the mode. There might be some places where like working with the mode is more tractable than working with the mean, but I kind of expect that like you collect a bunch of data like this and the mean still isn't great.
Well,
yeah.
As a silly example, add values are fragile. You can do this with a smooth min. And we expect human values to have at least this level of complexity. Now, ignoring for the moment negative outcomes, sort of people being tortured and stuff like that, if we can avoid those as well, then it seems that we have defined a very wide class of things that contains our preferred utility function, and that a average of this maximizer with huge amounts of power will get a positive result. Not nearly comparable with the amount of power that it has, because this is a small slice, but yeah, but sufficiently. But as I say, I'm not. This is confusing because what I'm saying is kind of the opposite of what is in the version I've emailed to you, or not the opposite, but a different approach, shall we say. But I just to repeat again, I feel that I think that lots of people consider the Goodhart problem, think that the mode and the mean are the same, and the toy examples that we have, they are. And I think distinguishing these two is very valuable, and I think adding extra meta-knowledge shows that the mean can be surprisingly good without even having to add any quantizers or other methods. And
that seems right to me.
Do people want me to say what I mean by the opposite of the Goodhart problem, or have I explained that? Okay, the opposite of the Goodhart problem, if you want, is when you prefer that the proxy, the mode, be maximized rather than the mean. If you have increasing returns, this is the kind of thing that might happen. Wouldn't
you always prefer the mean? Like if you take the mean of functions that have increasing returns, that would just make you go with the mode anyway.
Well, let's do a sort of example like the nails. The People's Commissariat for Central Nail Production has told you you need to maximize the number of nails, and their proxy function is pieces of steel, and you maximize that proxy, and these are terrible nails. Now there is if you call the proxy V and the actual nail the genuine utility function U, there's a delta. So let's see, consider V minus U minus V. This is the utility function on the other side. If U is here, V is there, this is the one that's on the other side. This is a weird sort of thing. And this utility function, so call it W.
I'm not following.
So this is U, this is V. There is another utility function at which V is exactly halfway between the two. Utility functions can be added if you have a scale. Assume we have a scale. They can be added, they form a vector space. So this is U, this is V. Other side of the vector, there's a W. And this W this W is something that benefits a lot. This is sort of like the utility that hates nails and loves pieces of steel. It would much prefer the V as stated than say a 50-50 chance between it and the true U. So if you want U, yeah, so, but this odd kind of utility function, notice how hard it is for me to describe in human parsable terms, because it makes no sense for a human. Because it isn't a human, I can describe it in terms of vector space, it's easy, this minus that there, but it makes no sense for you secretly do not want true nails, but you want more pieces of useless steel or something like that. It makes no sense for a human.
No, but like the W is the difference between the true utility, whatever that is, and the proxy, whatever that is.
On the,
right?
But no, it's not the difference, it's the other side. It's, let's see. So it would be V plus V minus U. V minus U is the delta between U and V. W is the negative delta.
V plus V minus U.
So
okay, so it's so here. Okay, now I see what you mean by the other side. But it's sort of it's defined in opposition to the true U. So
yes.
So no matter what the true utility function is, even if it's something inhuman, this W is always going to be worse than U.
Worse? Well, the point is that from W's perspective, it prefers a maximizing of V rather than a 50-50 chance between U and W. So it does not want the mean, which is 50-50 between U and W. It prefers that the mode or the middle is maximized.
Wait, so W prefers
W prefers that V be maximized rather than the agent be uncertain between U and W.
Sorry, like why is the mean of U and W not V? Because like if you're defining W in a way in which V appears to be the middle.
It is possible I am making a mistake in what I am saying here. Do I have the examples very clearly to hand? All I know is Goodhart. It's possible, sorry, that is, let me find this. The difference.
In the meantime, I can say that if Scott would like to break in and stop this question because he feels he has a better question, then Scott, by all means, go ahead.
The full version of what I was saying is here. I was not expressing it correctly. But just as there are things that fear Goodhart, there are things that anti-fear Goodhart in the same way. Every utility function, of course, would prefer that it be maximized, but the kind of ones that particularly fear Goodhart are compensated by other ones that anti-fear it. And the example there is more coherent than what I was rambling, and I got the definition of W wrong.
So have you thought about the consequences of the fact that you're averaging over utility functions. You're not averaging over utility functions up to affine transformation, which means that you're going to have a bunch of different copies of each utility function up to affine transformation in your class. I don't know. Do you have anything you want to say related to that?
that the normalization of utility functions is a very hard problem, that I have several posts on it showing how hard it is, and that maybe here we have more of a principled normalization. Like we can sort of compare with things like, I like ice cream and this TV show this much, and then we can at least rank the different utilities compared with that, possibly.
Yeah, I was thinking that here we have a kind of principled point that we might want to like call the zero, which is like choose a random utility function from your class and optimize it, which like that gives you a utility for each utility function, and we could like use that as the 0 point for normalization.
I think we need to, the 0 point is not enough for normalization. We need another point. Like my, have you heard of the population ethics, which is exponential in the number of people?
No.
Would you give that any probability whatsoever?
I tentatively don't believe in unbounded utility functions.
But the sort of issue with that is that if you give it any probability whatsoever, it doesn't have to be unbounded. If you give it anything but the tiniest of probabilities, then it'll dominate average utilitarianism, it'll dominate total utilitarianism, it'll dominate any theory of population ethics. Of course, this I think is ridiculous, so you need to penalize it by its span. That's the sort of min-max normalization. But yeah, I feel you have to normalize all these utility functions anyway to prevent that kind of bad behavior.
So I want to give a concrete alternative proposal to optimizing the average of a space of distributions of utility functions. So I have a distribution of utility functions. I will define a 0 point as I will define the 0 point as choose a random utility function and optimize it.
Okay.
And then instead of maximizing the average utility, I want to maximize the product of the differences between, like I want to choose something that is better than this. I want to choose a Pareto improvement of this by maximizing the product of the differences in utility. Assume we have a finite collection, but we can also do this with them.
So basically Nash bargaining equilibrium.
Basically Nash bargaining. Yeah, so I'm curious if you have Cash thoughts about what about like Nash bargaining versus Bayesian choice for maximizing the space utility. You're gonna copy another post in the chat, aren't you?
Well, I could, but let me try. And I do like the fact that I've reached the stage in my career where I can answer most questions with links. But what I was I'm trying to answer this. I don't like the Nash bargaining equilibrium because it doesn't feel natural. There might be some messy stuff around 0.
Yeah, I want to point out that the thing I'm proposing is not exactly Nash bargaining because I've defined 0 in kind of a weird way.
Doesn't matter. Once to do the Nash bargaining, you need to define a 0, and then.
Oh, I thought the Nash bargaining explicitly had 0 as like the threat points or something, but maybe not.
You've just defined a different threat point if you want.
Yeah.
Okay, so this has certain failures. We can come up with examples where it fails. It's generally to do with things that only maximize a tiny bit unless you give all your effort to it. And then the 1/10 trillion thing dominates the product. kind of thing. And yeah, so yeah, I think that's a problem. I'd go for one of the other ones, like what are the ones I came up with? So you can keep your 0 point. You define a utopia point where every utility gets its maximum expected value. That's not a point that can ever be reached, but you normalize those to 0 and 1, and you Pareto improve on that. That was, what was it, my mean worth bargaining solution, something. Anyway, something I came up with some time ago. Okay, so this thing is probably exactly the same thing as maximizing the mean.
Yeah, I think they're. Wait, I'm not sure. Oh.
If I choose the Pareto. Yeah, well, yeah, but within normalizations. So if you fix that normalization. So yeah, if you fix this is the mean max normalization. Why don't I recognize it? The mean action is pick one of them at random, maybe according to probability. The max is maximize only this one. Normalize each utility function to be 0 for the mean policy, 1 for the max policy.
Yeah.
Then, given that normalization, just normalize the mean. This is now what I've just described there.
Yeah. So are you?
Sorry for everybody else who hasn't necessarily followed my back catalogs from several years ago.
Are you? Yeah. So I don't know. I was originally interpreting you as just like not working up to affine transformation, right? Like when you're originally proposing the thing, you're just like take the average of the utility functions, and utility functions are just utility functions. They aren't utility functions up to affine transformation. They aren't like. Yeah.
The normalization question is a difficult one that I think is separate.
Yeah. Okay.
It's not separate, but it's something. At least for my method, or for taking the mean, you have to solve the normalization somehow separately before you do this, or while doing this, or whatever. More links, okay. I'm listening to questions while I go searching for links.
Yeah, I'm assuming that if there are other questions, they would pop up in the text chat.
No, I mean, I'm listening to what you're saying while I go searching for links to answer that question.
So so yeah, would you describe your position right now as roughly we should just like kind of ignore the normalization question and just like we have a distribution over utility functions that's coming from, I guess this is a question like, where by utility function I mean actually assignment of numbers, like distribution over bounded utility functions that are inside some interval and average them.
It is possible that some of the other methods, like the quantilizer methods, may have their own inbuilt normalization, which the mean method does not, which may be a point in their favor. But for the moment, at least I'm saying the mean and the normalization are separate questions here.
Well, I don't get why you're saying that. It seems like to take a mean, you don't have to normalize. Oh, well, okay. Yeah, sorry. I'm imagining like I have a space of distributions of utility functions on where utility is between 0 and 1. And I might have the same utility function up to affine transformation several times inside this distribution. And that's what I'm interpreting your proposal to be, which is just like completely aside from any question of normalization.
Well, if you if you take actual utility function representatives, as in actual functions, and you have a distribution over that, then you've already kind of normalized.
Yeah.
Let's see.
My
And here is the mean worth optimization, mean worth bargaining solution kind of thing.
So when I imagine trying to use this proposal and still being like killed by Goodhart, it's like, because I'm like, okay, I'm going to like specify this distribution over all of the things, and I just like entirely miss a dimension. And so when you're saying like enumerate all of the utility functions and give them all some weight, like by enumerate all the utility functions, you're enumerating all the utility functions within some space, and like you could imagine having a utility function that kind of like misses that space.
This is where the post in my email becomes the most relevant, and I can't really answer you without referencing it.
Okay.
I don't think of it as there's a distribution over these utility functions which might miss a dimension, but what happens when we see evidence that we've missed a dimension? How do we extend our current model? But this brings us way astray from this from this conversation.
Yeah, I mean, I don't know. I wouldn't call it too astray, because I feel like when I hear the proposal, the reason why I feel doom is because of the thing I just said or something.
Well, okay. Well, let's think a little bit more formally. If you have a dimension missing, and we use another method, like let's say quantilizer. If we're quantizing and there's a dimension missing, we've still got big problems. If most of the conservative methods have similar problems, except you could say that as a conservative method at the time, kind of keep things close to the training environment that catches these extra dimensions without realizing it. But it seems that is something you could do as a prior as well. So what if we're missing a dimension? Can we capture it in other methods that we wouldn't do it in mean?
So why doesn't quantilizer take like what? So the safety measure in quantilizer is basically don't stray too far from the original action distribution, which is assumed to be safe. So why doesn't this take care of extra dimensions?
Let's think. So you rank the quantilizer. So we have the proxy. We take policies that maximize it up to some extent. You're right. If we were very careful with the quantilizer, we may implicitly capture the extra dimensions. But there is no. So yes. So in that way, it is superior. But there is no clear. There's no clear. We don't. The Q in the quantilizer, we don't know what it means. Surprisingly, I have a post on that, and I'm looking for it. But yes, you are correct. It does seem that the quantilizer can capture extra dimensions is a
No,
sort
I'm,
of
I'm claiming that it just naturally does. Like.
Oh,
in the-
actually, no. Sorry, I'm revising that. No, it doesn't.
Okay.
Because the policies that are, say, 50% effective to do the proxy, there are some policies that will capture this extra dimensions, and there are some that will anti on this extra dimensions if the dimension is not captured in the proxy at all. Yes, so yeah, no, it seems that
my default understanding of a quantilizer is you like take some learned distribution of things that humans would do, and you like select a like top 1 percentile from that distribution. Is that not what other people mean here?
That's what I mean.
I was under the impression that as defined by Jessica, it was not that.
That might be the case.
I'm pretty confident that it is that.
Well, I would like to be able to answer, but it's taking forever, I think, because of the video.
Can you answer in Word?
I
and
think
not
you
in the
defined it
post?
as that in the post. Yeah, so okay, the post that I'm looking for, I defined it in that way. And in the post that I'm looking for, I linked to
Right.
Jessica's original thing. So either I misread her thing, or there are multiple definitions of quantizers floating around.
Yeah, so in general, you seem to use concept like words slightly different than I'm used to.
Sorry.
And it's sort of fine because you explain what you mean, but I also think that you're missing out on things other people have done because you don't notice like using.
I'm terrible at literature reviews.
Yeah, I like this, the idea of using uncertainty of a utility function as a safety feature is a really good idea that I've seen around for a while. And I posted a link to like where I first came across it in the chat.
I'm yeah, okay. Give me my phone, and I'm giving up on the Wi-Fi, and I'm just going to. But that is what I mean. I'm reasonably confident that that was what the quantizer was because I looked it up specifically for that post.
I think that the most likely scenario is that there were multiple versions of quantilizer in Jessica's head.
Actually.
That's very possible.
And like the one that got into the post is probably the one that you saw. And because I worked with Jessica, I probably like saw other ones.
Okay, so yeah, so
or just like I'm misremembering or something. It's possible that several people that I talked to all have the wrong definition of quantilizer.
So the kind of thing that you're talking about, I've considered sort of extension of apprenticeship learning kind of things. Bad game, or isn't it less wrong that there's a problem? Because my phone, which is on the network, not on Wi-Fi.
I had problem loading this wrong earlier today, but alignment forum seems to be up.
Okay, let's try alignment forum. I feel okay. Is this? Yeah. So let's refocus on the thing. The question is.
My current question is, what do you mean by quantilizer? Because it's not what I mean.
A quantilizer is an agent that I'm reading from that returns a random action in the top Q proportion of some base distribution over action, sorted by the expected utility achieved if that action is executed.
Yeah, so I usually think of the base distribution as like a learned distribution of what humans do.
Okay, I
maybe...
think of the base distribution as all the policies you can think of, or all the policies that the AI can think of.
Yeah, the version I read, the base distribution was supposed to be something that's reasonably safe to draw random action from.
Okay.
For example, human behavior.
Okay. Something that it's safe to draw a random but not an optimized action from. Okay. Yes. Then this, if it's safe to draw a random action but not an optimized action from, then this is intrinsically, this controls for extra dimensions that we might not have considered. If we are convinced that it is safe to draw a random action for it, which from human style behavior is definitely safe in the short term, I'm not entirely sure if it's safe in the long term, but okay. So yeah, that seems to be arguments that quantizers do have advantages.
Less wrong is in fact down. Yeah.
Okay, then that is learning, and how should I how conservative should the partial maximizers be? Okay, so this is the post that I was referring to, and I think the points of the post are still valid, even with the not quite as valid with a safer base distribution. The point was, if we know that the optimal one is wrong, and we know that the 0 is also wrong because it doesn't help, how do we know that it's safe? But as you say, going for, say, if we could draw 100 times at random and expect to not go disastrously wrong, then 99 percentile is probably safe in a similar way.
Not very powerful. We get 99 percentile actions, like 1 out of every 100 actions we take.
You could just do it with policies. Anyway, sorry, I'm starting to fade, I fear. And I think the questions are getting a little more wavy.
Should we call it?
Well, let's check if anyone has a last question, especially a sort of simple clarification question, which are easy.
Okay, I have a simple. What is the difference between a well-intentioned AI and an aligned AI?
The aligned AI is an actual objective. A well-intentioned AI is a thought experiment that allows me to explore new ways of possibly getting to an aligned AI. A well-intentioned AI, as I've described it, might still kill the universe. It's focusing on a different approach to the AI problems, or a different class of the AI problems. Maybe for meso-optimizers, the difference makes sense, but not for general AIs.
Are we allowed to ask this? I don't want to interrupt. I know that was your question, but afterwards, can I ask a naive question?
Go ahead.
Wait, Soren, did that answer your question?
Sure, go ahead.
Thank you. So you both work along with at Miri or with Miri. I have a question about a post. I think it was like it was from one of Yudkowsky's talks about AI alignment being like a cryptographic rocket problem, and I think it went on to describe the process by which you try to align it. So you began your talk today, Dr. Armstrong, with a discussion of like we don't have an AI, we don't have the code, we can't. It doesn't quite work the way one would hope it would if you actually had these things. So instead, you try to introduce, I don't know, a characterization or a definition, or at least Miri has discussed introducing the tools that would help one get what they called like a space plane to the moon. And they described it as like the principles of first derivatives and second derivatives towards getting us towards like rocket science. So how do you guys view AI alignment in terms of, given that we don't have any AI now, do you mostly view it as a problem of like getting the tools necessary for it, or do you go along the path of like, let's define what superintelligence is, even if it's wildly intractable, and then let's go from there? I've been looking at your work, but and some others, but I'm having trouble recognizing the difference between the two approaches. I don't know if that's coherent enough.
I ramble in many different directions and find many different ideas, because that's how my brain is wired. Maybe one, I always tend to make the assumption that it is a super intelligence, and that we can't constrain its knowledge except if it's in a very specific cryptographical way. The reason being that most solutions that work for that kind of anything, most solutions, not all, but most solutions that work for superintelligence work for dumber AIs as well. And Ali, I can answer your question with saying I can't answer your question right now.
And as a follow, thank you very much, by the way. And as a follow-up, Dr. Garrabrant, do you have any response to that question, or rambling?
Yeah, I think I missed it in part. I have two things that I think are adjacent that I want to say. Well,
Sure.
One thing I want to say is that like I feel like I should probably disclaim that, I don't know, we're talking a lot about things that are trying to like figure out how to get human utility functions into AIs, which like I kind of I don't know, like I wrote this Good Heart post, but other than that, which is like a very general thing or something like that, but this is like generally not like the sub problem that I'm thinking about most of the time, where like I'm mostly thinking about the problem such that if I can have a thing that is trying to like optimize reliably any hard objective I could write down whatsoever, like this is like the part of the problem that I am like have my sight on right now, where like there's value in the like reliably type thing where we want to like be able to direct something at doing a thing, but I kind of feel like from my point of view, if we could make a paperclip maximizer reliably, we would have solved a large portion of the problem. And so a lot of this is like out of the space that I'm like normally thinking about. And then another thing I want to say, possibly adjacent to your thing and possibly not, I don't know. It's definitely is the case that the way in which I view most of my time working on AI alignment related things is like trying to build up foundations without having like the direct, like without like having the direct use case. Like I have like a few different like use cases, or one to like resolve some uncertainty or some confusion around some area, but like I'm like trying to work with abstract enough objects that no specific like use case that I have in mind will be like the only way in which it might be used or something. And so like it does feel to me a lot more like trying to like develop calculus than trying to like build a rocket, in the sense that like it feels like it's like a thing that you need to do before building a rocket. And I feel like it's hard to be able to look at the problem of building a rocket and figure out what the right type of calculus to develop is without actively working on building a rocket or something. And so maybe I'm doing it very badly, I don't know. But I do think that like most of my time is like most of the like analogies that I'll draw and stuff, if you try to think about them as being directly about AI systems, then it might like miss the point that I'm trying to point out or something.
Okay, thank you very much. And then I have one more, but I believe some other people might have questions too, so I want to yield in case they do. If not, then I'll ask. How do you, as a researcher at Mary, how do you feel about the choice to not publish any research? So I believe one of the last publications that I saw from Mary was the logical inductors paper that you are the primary author on. How has that changed your perception of researching? Has it been a net benefit to you personally? I have no inside view of this, but it's weird from an outsider perspective, from someone who's looking at Mary's work for quite a while and then seeing a complete hiatus on that.
In terms of net benefit on me personally, there are definitely ways in which it's good and bad. Two ways in which it's bad is that it makes collaboration harder. Another way that it's bad is that sometimes I would want to use writing stuff up as a motivation for myself to formalize things more or something. It's I have all these ideas in my head, and the process of writing them down is a motivation to do a certain type of thinking that I have to externally motivate myself in a different way to do, or something like that. But a large part of, I don't know, there's a point that I want to make about publishing, which is that I think that it depends a lot on whether you expect, I kind of expect that the kind of stuff I'm working on has a chance of developing something really cool and a chance of not, and the incremental progress is not as exciting or something, versus if I was working in a field that was more close to a lot of other people, then the incremental progress would matter. I would have to get my incremental progress out so that other people could get more incremental progress on it, and it can build up through a bunch of individual small jumps or something, versus I think that I am trying to do some variant seeking, trying to find some large jumps in the way that we're conceptually thinking about the problems, such that the cost that I pay by working privately until I have something that seems really interesting, and then deciding whether I want to share it, and then putting in the work to sharing it, is not that much of a cost, because it's the sharing of the incremental stuff doesn't actually help that much, because there aren't a lot of other people that are working on the exact same things that I'm working on in the same way. Versus if I was in ML, there would be a lot of people who are working on very, very similar thing in a very similar way, and so there'd be a lot more benefit sharing.
I'm obviously a lot more conventionally academic, and also some of the way I work is generating random ideas, and there it's much better to sort of toss them out into a less wrong post and move on and see if other people develop them. So yeah, I probably, my reckon is I disagree with the Mary's decision at first order, but I also trust that they've thought it through at second order.
Gotcha. Well, thank you both for your time, and thank you for answering the questions. I sincerely appreciate it.
Okay. Thanks,
then
everyone.
I would like to just say two more things. And the first thing is a big thank you to both Stuart and Scott for coming here. I appreciate it very much, and I've learned a lot, and I think everybody here has enjoyed it very much. So thank you for that. And then the second thing is just in the beginning, which said that there weren't actually no implementation of any of this. And actually that turned out to be wrong, in that JuneQ has made a actual explicit implementation of a utility function for superintelligence, and also an implementation of meta-semantics that's been published at methoethical.ai. And next week I will try to give a presentation on that in the reading group on Tuesday at this time. So I hope to see some of you there.
Okay, thanks.
So that should be all. See you next week. Bye.
Bye.
I'm away from a computer, Soren. Is there any way you could hit Command A and copy comments, or no? Because there were a lot of links shared and some questions.
Yeah,
And I don't know a good way of saving any of this for